Hi everyone, welcome to Java Techie. In our last video, we understand Saga Choreography design pattern with hands-on example, right? So today we are going one step ahead and diving into Saga Orchestration design pattern, which is another powerful approach to compensate failures in microservice architecture with a smarter and command-driven workflow pattern. Okay. So before we jump in, if you missed the choreography tutorial, I strongly recommend watching that fast because in this video we are going to reuse the exact same microservices and the orchestration flow builds directly on top of it. Okay, don't worry, I'll share the link in video description so that you guys can refer to the choreography design pattern. So well, by the end of this tutorial, you will clearly understand when to use orchestration and how to implement it with a real-time hands-on example. Okay, alright. So without any further delay, let's get started. As we know, in Saga choreography approach, each microservices talking to each other with Kafka events. For example, booking service publish an event to the seat inventory service. Similarly, seat inventory service publish an event to the payment service. And again, the reverse path for failure compensation. This works, but as the system grows, service starts depending on each other's events, and that creates tight coupling between microservices. And if one service fails, then every other service needs to know how to compensate on its own, and that becomes really hard to manage in Saga choreography design pattern. So to solve this problem, Saga orchestration approach comes into the picture, and this changes everything. Instead of service talking to each other directly, we introduced an orchestrator layer, a single brain that controls the entire workflow. What this orchestrator does, it receives the request and send command to the appropriate microservices, listen back their responses, and based on success or failure, it decides the next step. For example, if all services succeeded, well and good, there is no risk. If any service fail, the orchestration send compensation commands to roll back the previous operation. This way, the individual services stay loosely coupled and the orchestrator become the brain that ensure the whole workflow remains consistent and failure resilient. That's the real power of Saga orchestration design pattern. Well, now let's break down the actual flow and see how we can implement the orchestration approach in our movie booking system. Trust me, if you understand this flow once, you'll be able to code the entire implementation blindly with full confidence. But if you miss the flow, everything else will feel confusing to you. So stay with me and try to understand this end to end in one go. Okay? So we have an orchestrator layer. Let's name it as booking orchestrator. This guy is the brain of the entire workflow and it decides what to execute in the flow. Okay. Imagine a client send a booking request. At very first step, the orchestrator will receive the request and publish booking command event to the booking service. At the same time, it also publishes seat reservation command to the seat inventory service through Kafka events. Okay. Next, both booking service and seat reservation service or seat inventory service consume this event, process the logic, and then publish either a success event or failure event through the Kafka. Okay. Now this orchestrator listen to all these outcome events from all the microservices. If the orchestrator receive a seat reservation failure event, then it immediately trigger a rollback command to the previous action, which is nothing our booking service. He will say, hey, something broke, please undo your changes. But if orchestrator receive a seat reservation success event, then orchestrator publish a payment command event to the payment service saying that, hey, seats are locked, please collect the money or process the payment. Next, payment service consume the event and process the payment, and again it send back either success or failure event to the orchestrator. Now again orchestrator listen to that event and it will check If it found succeeded event, then all good. There is no failure. The orchestrator simply marks booking as confirmed and persists to the DV. Okay. If orchestrator receive payment failure event, then orchestrator triggers rollback command to set inventory service and also parallelly send rollback command to the booking service. Everything gets cleaned up in one shot. This way, our booking orchestrator act like a traffic controller. Continue when all are good, all flow are good. Roll back when any step fails as part of the flow. How simple is this, isn't it? Instead of each microservice shouting at each other like a Bollywood family drama, the orchestrator centrally manages the flow, when to continue, when to roll back, and what should happen next. All decisions are made based on the clear success and failure events from each and every microservices. Simple, clean, and reliable, right? Well, this flow might look complex, but don't worry. Once we start implementing it in code, this flow will become super clear for you. I'll walk you through step by step. I hope you got some clear concrete picture of what is Saga orchestration approach and why it is better than the choreography design pattern. If you are with me, great. Let's jump straight into the implementation and see everything in action. So we'll follow this particular architecture as it is to understand Saga orchestration design pattern. So please try to picturize this flow in your mind so that it will easy for you while writing the code or while understanding the code. Okay. At very first step, what we need to do? We have this booking service, seat inventory service, and payment service. That is what we created in our previous Saga choreography example. Right. Now at first step, we need to create this new microservice called booking orchestrator. So let's create that project. Now what I'll do, I'll go to the Spring Initializer and we are using latest Spring Boot version 3.5.7. Now let me add all the required field here and observe one interesting configuration here. Now in latest Spring Boot version, you can choose the configuration whether you want properties file or you want YML configuration. I believe this is something new. So let's try it out. We'll go with the YML configuration. Now let me add all the required dependency. We need web dependency and also we need Kafka dependency because this orchestrator will publish and consume the events. Okay. So let's add these two dependency. Rest other dependency we'll add manually. Now let me generate the project and also let me import the same project to our IntelliJ IDEA. So this is our project. Now go to the pom.xml. The version is same 3.5.7. Now what we'll do? I will add two more dependency. One is Swagger dependency and second one is our common jar. Okay, because from this particular orchestrator I want to reuse the DTO and all the events classes. Okay, that is what we kept inside our common jar file. Now what next? Let's go to our application and enable all the Kafka related configuration because this booking orchestrator will act as a producer and consumer, right? So go to the main resources. Can you see here? It created application.yml class for us. Now let me add all the Kafka related configuration here. So we have defined the bootstrap server, then key serializer. I mean it's just a basic producer and consumer configuration. Okay. So server port for this orchestrator layer is 8181. That's it. Now if you'll go and check the flow, we are all set to start coding our booking orchestrator layer. So what will be our first step in booking orchestrator? Let's start a Saga or let's start booking process. So for that what I will do, I'll just create a new package service. Then in service I'll create a orchestrator class. I can name it movie booking orchestrator. Okay, this is the class where we'll start our movie booking process. Now since this is our orchestrator or service, annotate @ service I'll add SL4J for logging. Since we didn't add the Lombok dependency, I'm not getting that option. Let me update my pom.xml. So I have added the Lombok dependency now. Now let me import @SL4J. All good. Next, let's define a method from where we'll start the booking process. Public. You can give any name. It will accept booking request. Now, what we need to do here? Go to the flow. Booking orchestrator, what it does at first step, it publishes the booking command event and reservation command event. Okay, booking command event to the booking service and reservation command event to the seat inventory service. So let's create these two commands and publish it to corresponding microservices. Now let me keep a note here. So first let's build the booking created event. Then we'll publish through the Kafka. For that, what I'll do, I'll just inject the Kafka template here. So first, let's create the booking created event. Let me create an object of it. Now get all the field from this particular request and map to your booking created event. What is the first argument? Booking ID, which must be a dynamic value, right? So what I'll do, I'll just define a private method who will generate the dynamic string random ID for me. Private string now just map the value here. What is the first argument? Is your generated booking ID. Then you can pass all the field user ID, show ID, seat ID and amount. And while creating the booking request, you can keep the status as a pending. Once all the process will be succeeded, then system needs to update it to confirm or anything else, okay, or reserved anything else. That's fine. This is our booking created event. Now what we need to do, we need to publish this event so that this booking service can consume it and process it. So for that, the simple step, you can use Kafka template dot send. We can give the topic name. What is our booking event topic? You can find it from the Kafka configuration properties that is there in our commons class, right? If you will go and check here, we have defined all the topic and their consumer group. So for booking event topic, you can use this class that we already discussed in Saga Choreography. What is there in this commons and all, I don't want to reiterate again. So you can use this commons jar to get all the topic and group information. Now go to the code, movie booking event topic, and what is the key? Key is nothing, your booking ID. So better get it first so that you no need to recalculate it again and again. Just give the key as a booking ID and then value as a booking created event. Okay, this is the first step. Send booking created event. Now similar way, you also need to prepare the seat reserved event and needs to publish through this Kafka template. Okay, let's create the seat reserve event request or seat reserve event payload. You can create this particular object seat reserved event because all the information you will get directly from this request object, right? So you can happily just map the value from the request object. Now what next? Once you have this particular seat reserved request, you can publish that through the Kafka template. Kafka template dot send. Now to which topic you need to send? You can use, see, if you go and check the comments, you can use, see, this seat reserve already has a topic, seat reserved topic. But since orchestrator giving the command, so I am using a different topic called seat reserved command. So I have segregated request topic and response topic for this seat reservation or seat inventory service. Similar way, request topic and response topic for this payment service as well. Okay, if you will not segregate this, then your application will keep ping and pong to each other through the Kafka events. Okay, so it's good to have a separate topic for consumer and producer, or just for request and response. Okay, now all good. What I'll do, I'll go to the booking orchestrator. Now here, what topic I need to use, I'll get it from the Kafka config properties dot seat reserved command topic. This is the topic my seat inventory service should listen to it, but my orchestrator will listen to the seat reserved topic, not to the command topic. This is just to send the command request to the corresponding microservices. Okay, now pass the booking ID here as a key, then pass seat reserved request, or what is the variable we have defined. Now let me add a log statement for both the flow. Add a log statement here. Now what you can do, you can also remove this. You can import it as a static import statement. Okay, so let's keep it short. Now after publishing the seat reserved request, you can also add a log statement here. Okay, all good. Now I'll just simply return the booking ID. You can make this code more better. Let's do that. So what I'll do, I'll move this to a private method so that our code will look clean. Okay, so extract to a method. I'll name it build. We are creating a booking created event, publishing to the topic so that booking service will consume and process it. Similar way, we also create a seat reserved event and publish to the seat reserved command topic so that seat reserved or seat inventory service will consume it and process it. All looks good so far, right? Now since we are publishing these two commands, let's go to their corresponding microservices and consume it and process it. That is what the flow, right? If you understand it, these two commands already we sent, booking command and seat reserved command. Now this booking service and seat inventory service needs to consume that and process that, right? Go to the booking service first. Now in booking service, we have the Saga choreography logic. Let's not toss that. I'll create a separate listener class who will consume from the orchestrator. I'll name it annotate @component. Now this movie booking consumer will listen the event from the orchestrator. Okay, so write a listener method here. Now which object it will receive? Booking created event. Now what next? Let's inject the service and define a method. Call that from this listener. But before that, let me annotate the Kafka listener. Which topic it is listening? Movie booking events topic. And you can define the consumer group specific to your microservice. All good. Now what I'll do, first let's define the try catch and call the service. But before that, let me inject the service class here. I can annotate required arg constructor. So just define the try catch and define a method service dot process booking. Okay, let's create this particular method in our book service. Now here we will reuse the same existing code. What we are doing here, we will reuse the same code, but we will do some little changes in the flow. Okay, so first let's add a log statement. Booking service process booking for user ID for show this. So you can change it to the request. That's fine. Okay, now what next? Now if you understand this particular flow, first time orchestrator will send the request to this booking service saying that okay, the booking created status is pending. Now once seat reserved succeeded and payment succeeded, again you will get another command saying that okay, your booking status is now confirmed or processed. So it will get two things, one for the new state that is pending, second for the update state that is saying that okay, your booking ticket is confirmed now. Okay, so for that what you need to do, You can define two different methods for save and update. What I will do, I will just simply use this particular method to handle both save and update scenario. So first I will check booking repository dot find by booking code id, which I will get from the request dot booking id. If this particular object exists, then I need to call the update. If there is no record with this booking id, that is the save request. That is what the simple way I can handle it. So I can define booking details, or better name it existing booking. Okay, at first place I am checking whether there is any booking available for this booking id. If not available, if existing booking equal to null, then it's a create scenario. Just add a log statement and you can map a booking object here. Okay, I'm using the same mapper where I'm just converting the request to entity. Okay, read it, booking request to entity mapper. Else it is a update scenario. What you need to update? Only you need to update the status. So for that you no need to get whole object, get the existing booking, get the new booking and just map it. So let me define a private method, update existing booking, existing object, new object, just change the status. Okay, that's it. From the event, whether you are getting the pending event or confirm event or fail event, whatever the event value you are getting, just update it accordingly. That's it. Okay, so I can simply call here booking equal to update existing booking, give the existing booking object and our event, which is nothing the request. That's it. Just add a log statement, booking service, updating existing booking for id this. That's it guys. All good. Okay, now this consumer will receive the request. Based on the event status, it will just keep update or create a new booking record in db. That's it. Now what next? Go to the orchestrator. We publish this event from the orchestrator, we consume it in our booking service. Now similarly, this is the command orchestrator sent to seat inventory service. Now let's consume it. Go to the seat inventory service. Here also I will not touch existing code. I will create another listener. Now define a method here, public void on seat reserve. What input it will receive? Seat reserve event. Define the Kafka listener and define the correct topic. Now as I already mentioned, this seat inventory service needs to listen to this command topic. Okay, just add a import statement, but it will publish its success or failure result to the seat reservation topic, not the command topic. That is how we have segregated the request and response for a specific microservice in event based approach. Fine. Now let's add a log statement, seat reserve event listener consuming seat reserved event. Now who is sending this particular request or event? Orchestrator. Orchestrator can send success or failure event of seat reserved, right? Now if you see the flow here, first time it publish success event reservation command. Okay, what if there is a payment failure? It will publish seat reservation failure event, right? So for that reason what we'll do, we'll add a check here. If event reserved, if it is success, then book the seat. Okay, else simply roll back. Is this clear? This is the simple fundamental, because this is the common place will consume the event from multiple microservices. From the orchestrator will listen to each and every success and failure, and it send the event accordingly. If it is a success, book the seat. If there is a failure, just roll back it. Again, already we have the logic in our seat inventory service. We are going to reuse that code. Private, first let's inject the seat inventory service. I will use @required r constructor. Now in this service, on reserved, you can call reserve seat, something like this. Give this particular event. In failure, you can simply define service dot create a method like this, pass the event. Correct? Now let me also add a log statement for better visibility. Now on failure, I'll also add a log statement so that we can easily track the flow. Seat reservation failed for booking ID this, rolling back any logged seat for this particular booking ID. That's it. Now let's create this particular method. Now let's copy the code from previous logic. So this logic handle booking we can reuse here. You can also rename this particular method, guys. Better let's do that. Rather than copy paste, let's do that. Go to the seat inventory service, change it to the reserved seats, change the event type to seat reserved event. Okay, that's it. What it does, first it will fetch the available seat based on the show ID and seat ID. If it is available, okay, then it simply log the seat for that particular user and update in the DB and publish success event. See here, if that seat is not available, it will publish failure event. Okay, now I will also change this method name. Go to the seat inventory service, change this particular method name. Rollback seat reservation on failure. All good. This is our consumer. Now what I will do, better let's comment all other consumer, otherwise it will be confusing. Why it is crying? Event dot booking ID. That's it. Is this clear, guys? Orchestrator will publish the command to this particular topic and we don't know the event status. It could be a success or failure. In case of success event, we are reserving the seat, and if all went well, we are publishing success event back to the which topic. See here, we are sending to this topic, seat reserved topic. This is the topic where we publish our success or failure response event. Okay, that is what will be consumed by our orchestrator again. You remember this flow. Each service will publish the event either success or failure to the topic, and that is listened by our orchestrator. Okay. Now on failure, we are publishing the failure event to the same topic. Now if you observe here, if orchestrator send rollback event, simply what we are doing, we are changing the state of seat to the available and removing the current booking ID from that entry and updating the DB, and again we are sending the failure event. Is this clear? Failure event to whom? Seat reserved topic. So I believe we are on the same page till this point. Now if you understand the flow, what we have done so far, our orchestrator publish command event to the booking service and seat inventory service, and both the service consume the event and processed it. Now since there is no complex logic in booking service, I am not sending back any event to the orchestrator, but in seat inventory service we are publishing success event and failure event. Now what orchestrator will do, he will again listen to the seat inventory service response. Based on that, if it is success event, he will process the payment. If it is a failure event, it will simply give a command to the booking service to roll back the changes. That's what the next task. Okay. Now let's write a consumer in our booking orchestrator to listen to the seat inventory service success or failure response. Okay. Let's create a consumer in orchestrator. Go to our orchestrator, booking orchestrator, Now I'll write another method, public. You can give any name, okay? On seat reserved, what event it will listen? Seat reserved event. From whom? Seat inventory service. Now define @Kafka listener. You can import the static import statement. Now observe carefully which topic this orchestrator listening. Seat reserved topic, not the command topic, because we are publishing the command through the command topic as a request to seat inventory service. Seat inventory service publish its success or failure event to this particular topic. That is what my orchestrator listening. Don't be confused. In previous example, we mixed up everything with the same topic. Now in this particular orchestration, we segregate topic for request and response. Okay, that is what keep in your mind and try to understand the flow. Now here, what next? Again, this particular orchestrator can either receive the success or failure event from set inventory service, correct? Now first let me add a log statement. Movie booking orchestrator consuming seat reserved event for booking ID this. Now what we need to do? We need to check if orchestrator received success event, then what is the next action? Now if you understand the flow, if orchestrator receive the success event, then orchestrator will publish the request for or publish the command for process the payment, correct? See this green flow. Now let's define that. If orchestrator receive the success flow, he will simply do send payment request or initiate payment, anything you can define, give the event. Else simply send the rollback command to whom? Check the flow. The rollback command on failure to booking service. So you can simply define send rollback to booking service. Give the event. Just add a log statement for better visibility. Orchestrator published booking payment event. Okay. On failure, it will send failure event. Just add it. Orchestrator publish booking created failed event to booking service. On success, publish the event to payment service for process. Same flow guys, there is nothing to confuse. On success, orchestrator asking to process the payment. On failure, orchestrator asking to roll back the previous action. That is what we are doing. Now let me define these two methods. So what you need to do, you have this seat reserved event, create the object of booking payment event, map all the value from here, simply publish through Kafka. Okay. We have created booking payment event object by getting all the value from this parameter, and we are publishing to see the observe here. Payment events command topic. This is my request topic or input topic to application. But the response topic will be payment events. Remember this again. Now go back. Now here that is for on success scenario. On failure, we'll send fail event to booking service. So simply create the booking created event with status fail and publish it to the movie booking events topic. In booking service also you can define the command topic and response topic like this, like the way we have done for payment and seat inventory. But since it is just a simple application which is updating the DV, I have not defined two different topic. Okay, you can do that if you want. All good. On seat reserve, send the payment request so that payment microservice can consume it and process it. If there is a failure, send the rollback to the booking service as per the flow. Okay. Now what is the next step? Orchestrator send the payment request to payment service, or orchestrator send the payment command. Now this payment service will listen to this particular payment command and execute it then it will again publish success or failure event based on the output or based on the execution logic. Now let's consume the payment command event in this payment service. So let's write another consumer in the payment service to consume this payment command event which is sent by this booking orchestrator. So I'm keep iterating the same word so that it will fit on your mind rather than remember the things. Okay. Now let's go to the payment service. Payment service also we have write the logic. Let's not touch that. I will create another listener class. You can name it payment event listener. I'll copy these annotations. Then I will also inject the payment service. Here also define a method for consuming the events. Public void. The input type will be booking payment event which orchestrator will send. And you can define the Kafka listener. Topic, it will listen to the event topic, command event topic. Okay, that is what the standard we are following in this orchestration. All good. Now what you can do, you can simply define the try catch and you can define payment service, process payment, any methods you can define. Now go to the process payment, we will reuse the same method by changing the object type. Go to the process payment and here you can change it to the booking payment event. Okay, there is couple of compilation error, let's fix that. Booking payment event. So this is the simple service in payment service, there is no DB integration and all. This is very simple logic. So we have added a log statement. Then to simulate the failure scenario, we have added if the amount is greater than 2000, gracefully we are throwing the failure event. Okay, otherwise we are sending the success event. Now observe this publish payment failure or payment success event, we are sending to payment events topic, not to the command topic. Okay, all good. What is the error then? Okay, it is being used in different place. Let's comment that this consumer, right? This is our listener. Now what happened? Orchestrator, see here. Orchestrator send the payment request on seat reserved success event. Orchestrator listen to it and send the payment event. Now this payment service consume that event. Now either he will send the on success event or on failure event. Correct? Now who is listening to that on success or on failure event? Orchestrator. Now once orchestrator see okay payment succeeded, then he will simply mark the status as a confirm. Okay. If he found status failed, then he will ask roll back to this particular seat service. Correct? Now let's write another consumer in orchestrator to listen the payment service success or failure event. Okay, go to the orchestrator. I'll simply copy this, we'll just change the parameter. On payment event or on payment status, it will receive the booking payment event. Okay, which topic it will listen? Payment event topic. Now here again what you need to do, let me remove this. First let me update this, otherwise we'll confused by seeing the log. Okay, consuming payment for this. Now you have the booking payment event. You need to check what orchestrator need to check whether payment event is succeeded or failed. Okay, that is what we are doing here. This guy is done. Payment service is almost done. He sent the event on failure on success. Now orchestrator will listen to these two events and based on success and failure, he will do the necessary action. Red color for failure, green color for success. Okay. Now what he will do? He will simply check if event dot payment completed. If it is a success scenario, update booking status to confirm. Else send rollback command to seat service, seat inventory service. Okay, so let's do that. Now let me create a booking created event with status confirm, so that we'll publish to the booking service saying that okay, payment is completed, all good. We'll simply update that. See this green part, this is what will send by the orchestrator. Okay, let's do that. So you can do something like this. I mean, it's straightforward, no rocket science is there. We are creating booking created event with the status confirm, and we are sending it to the booking event topic, so that booking service will consume it and simply update the booking status in DB saying that okay, this event is confirmed, all good, I can enjoy the movie. Okay, now for better visibility you can do one thing. You can also define a private methods to make your code clean. Now in rollback also you can send the failure event to seat inventory service command topic. Okay, it's again very simple. Build the object seat failure event, send it to the seat reserved command topic, that is what the service is listening to, and all we are sending it from the orchestrator. Okay, now what will happen once seat reserved event, the failure event will received by our seat inventory service. See this, what it will do, it will check status. Okay, I got the failure event and it roll back it, simple. Okay, each things will be handled by orchestrator here. Orchestrator will listen to each service event, whether it is success or failure. Based on that, it will again send the command. Okay, if it is success, do the next step. If it is a failure, roll back the previous action. Like that, this is the guy who act as a traffic controller to deal with the success and failure scenario. Okay, this is what the simple flow. Now go to our orchestrator. At first view, this code might be confusing, but if you will try to relate the flow we have discussed and code line by line, this is really dead easy, guys. There is nothing to confuse. Now, what is the next step? Now, if you understand, user will now send request to whom? Orchestrator, not booking service. So in orchestrator, you also needs to expose an endpoint. We'll call this particular method create booking. So what I'll do, I'll simply create a controller package here. Now simply define a controller class, movie booking orchestrator controller. Very simple logic, guys. No rocket science. We just inject the orchestrator and simply call the create booking method by giving the booking request. Okay, all good. Now let's test this out. Okay, so for that, first let me start the Kafka Zookeeper and Kafka server. Zookeeper, then start the Kafka server. All good. Now let's start each and every service. Now start the booking service. All 4 microservices, I'm going to restart them. So it seems all service is up and running. Let me clear the console. Meanwhile, let me also show you the database structure. So if you observe, there are couple of screen, seat number and specific show ID. Okay, so if you see here, show ID 101, A1, A2 seat, these two are available. Similarly, there are few available slot for a show ID and few are already locked and reserved. Okay, so you need to send request for available seat ID. Now what I'll do, I'll open the Swagger. Meanwhile, let me see the orchestrator is up and running. Yes. Now go to the Swagger, try it out and send this request. Show ID 101, A1 and A2. These are two available seat. User ID is this, amount is 1000. Now we are trying the happy scenario. So let's run it and we'll see the logs to validate how the flow is working. Okay, let me send the request. Now you got the ID, which is nothing your booking ID, right? First, let's validate the DB, then we'll double check the logs. These two seat logged now. Check the booking table. It seems something wrong in our booking service. Record is not getting inserted. Let's do one thing. Let's debug it. Let's check the log file first. So creating new booking for ID this, then consuming booking event for ID this. After payment success, orchestrator send it to mark as a confirm. Okay, let's see. Okay, so I got the issue. We have created the booking object, but we are not persisting it to the DB, right? So let's do one thing. Let's save it to the DB and also log that. Fine. Let me restart the booking service. It's up and running now. Let's clear everything. Go to the DB and I will update this table as well so that we can reuse the same value. Make it available again and remove the booking ID mapping from this entry. Now let's send the request again. I'll change the user ID to RAM. Send the request. We got the ID. Now let's validate in the DB. So the ID is mapped here and these two entry A1 and A2 is logged now. Now if you check the booking table, you'll see the entry now with status confirm. Okay, user ID is RAM and this is what the seat ID. Now what we can do, let's understand the flow, the way we have designed the orchestration pattern, whether it is following the same rule or not. Let's start with the orchestrator. This is the new ID. Now what is the first action in orchestrator? Publish booking created command. Okay, then publish seat reserved command. Now forget about this. We'll come back here. Now publish booking created event. Go and check in the booking service. What is the first action item? If you see, once orchestrator send the booking command event, your booking service listen to that particular event, processing booking for user RAM for this show ID. Since this is the new record, it is creating a new booking for this. Then what next? It insert the record. Then booking saved reservation ID is this. Okay. Now if you go back to the flow again, booking service consume the booking command. Now let's check in the seat inventory service. What is the first action item? It consume the seat reserved command event, processing booking created for this, publish seat reserved event. Okay, seat log, seat reserved successfully. So it published the success seat reserved event. Now orchestrator will consume that. If you see here, what orchestrator does here? Consuming seat reserved event for booking ID. Okay, so again, if you understand the flow, seat service consume the event and it send the success event. Okay, it went to the orchestrator. Orchestrator listen to the success event, then he must trigger the payment request. See here, publishing booking payment event request to the payment service. Now orchestrator send the payment event. Now who will consume this? Payment service will consume that, right? Let's see what it does. It consume the payment event, process payment event, send the success payment event. Once it send the success payment event, what it will does? It will simply update the booking status as a confirm. That is what we are doing here. Now if you see here, go to the orchestrator. What orchestrator does? It again consume the payment event, then it find okay the payment event is succeeded, so it update the status to confirm. Okay, that is how you are seeing confirm here in the booking table. Correct. Now let's try the failure scenario. then we'll understand real importance of Saga orchestration design pattern. Let's run it. I'll not use the A1 and A2, rather we can go for this 202. Okay, B1 and B2 is also available. Let me copy this number, go to the Swagger. Meanwhile, let me clear the console for all the modules. All good. Now go to the Swagger, increase the amount, make it 10,000, because to simulate the failure scenario, we have set the limit to 2000. If it exceeds 2000, forcefully we are throwing the exception, or forcefully we are breaking the payment flow. Okay, this will be B1, B2. Now let me send the request. We got the response body. Now first let's check the log statement. Go to the orchestrator, filter with this ID. What is the first action? It publishes the booking created event. It publishes the seat reserved event. Then what it does? Seat inventory service, execute it. Then it publishes the success and failure event which my orchestrator consumed. Consuming seat reserved event for booking ID this. Okay. So since seat reservation is succeeded, it publishes the payment event. Can you see here? Request to payment service. Now once payment service execute, again it will send success or failure event, and that again will be consumed by my orchestrator. Orchestrator consumed it. What it found? Okay, since I found the payment event is failed, I need to roll back the seat reserve related stuff. So I am publishing seat reserved event to release the seat or to make it available for other user. And I am marking the booking status to failed instead of confirm. Okay, so you understand the flow, I guess. This is the failure scenario. Now if you see here, in our use case, what happened? Orchestrator send the request command to the booking service and seat service. Booking service execute, update the DB. Seat service execute and publish the event. In our case, it published the success event. So orchestrator again request for the payment command to the payment service. Now payment service consumed it and found there is a failure, so he published the failure event. Now once orchestrator found okay there is a failure, what it does, he send the command to roll back the changes to the seat service. That is what we are clearly seeing in our logs, isn't it? See here. Now if you go and check in the payment service, you will find the failure, publishing payment failure event. Now if you go and check the seat inventory service, see this, seat released successfully for booking ID this, publishing seat reserved event for this, seat reservation failed. Whatever we have discussed theoretically, that is what we are able to see in action now. Now if you validate the DB, check the booking table first, see the status, failed. Now you will find the entry here, that is fine. Now check the seat inventory service. What is the status here, guys? B1 and B2 still available and not mapped to any booking ID at this moment. Are we good here? Great. And that's it, guys. We just implemented Saga orchestration design pattern end to end. Now I believe you get some concrete picture with hands-on example. Now you will able to answer how an orchestrator coordinates the entire workflow, how it handles success and failure scenario, and how it keep all microservices consistent without letting them shout at each other. So if this video helped you understand the difference between choreography versus orchestration, please hit the like, share and subscribe button. It really motivates me to bring more such real-time microservice content for you. So just give a try and let me know in a comment section if you have any doubts. Keep learning, keep coding. I'll see you in the next video.